All right, let's talk about one of the most famous concepts in all of economics, the demand curve. Now, you've probably seen it a million times, but today, we're not just going to look at it. We're going to build it from the ground up, starting with the choices you and I make every single day. So yeah, we all know it slopes down. Higher price, less demand. But why? Where does that rule actually come from? It's not just something an economist made up. It's the logical result of one single person trying to be as happy as possible with a limited amount of money. And to really get it, we have to start with that one person's choice. So first things first, let's lay down the building blocks. We need to get inside the head of a consumer and understand their fundamental problem. Think about it. You have a certain amount of cash, and there's a world of things you could buy. How do you possibly decide on the best combination of stuff you can actually afford? That's the puzzle we need to solve. Now, this brings us to something that sounds a bit technical, the demand function. But don't let the name scare you. It's actually super simple. All it's saying is that the amount of a good you decide to buy, let's say coffee, depends on three basic things: the price of coffee, the price of other stuff, like tea, and of course, how much money you have. That's it. This right here is the consumer's sweet spot, what we call consumer equilibrium. Okay, so think of that curved line, the indifference curve, as a map of your happiness. Any point on that curve gives you the exact same level of satisfaction. Then you have the straight line, your budget constraint. That's just the hard limit of what you can afford. So where's the best possible point? It's right where they just barely touch. That single point of tangency is the absolute most happiness you can get for your money. And that's our starting point. Okay, foundation laid. Now for the main event. Let's see what happens to this perfect little choice when we start messing with just one thing, the price. Let's start by plotting our first point. In the top graph, you can see our consumer has found their sweet spot, point A. At that price, PX1, they choose to buy quantity X1. Simple enough. Now look down at the bottom panel. We're just going to take that exact information, the price and the quantity, and make a new point with it, which we'll call A prime. That is the first brick in our demand curve. Now, let's shake things up. What if the price of good X suddenly drops? Well, your money instantly goes further. That budget line pivots outward because you can now afford more stuff. And because you can afford more, you can reach a whole new level of happiness, a higher indifference curve. You find a new sweet spot, point B. And at this new point, you naturally decide to buy more of that good that just got cheaper. And this right here is the entire logic in a nutshell. We take that new choice from the top graph, the new lower price PX2, and the new higher quantity X2, and we map it onto the bottom graph. Boom! We have a second point, B prime. You can already see it, can't you? A lower price led to a higher quantity demanded. The shape is starting to emerge. And we could do this all day long. Imagine the price drops again. Same story, right? Your purchasing power goes up, you reevaluate, you find an even better point C, and choose to buy an even larger quantity X3. Each time the price falls, we get a new data point that confirms the pattern. Now, if you connect those points up top, A, B, and C, you trace out what's called the price consumption curve. But the real magic, the whole reason we're here, is what happens when you connect the dots on the bottom panel. You connect A prime, B prime, and C prime. And there it is, the individual demand curve. We didn't just assume it, we built it. Piece by piece, from the simple, logical choices of one person trying to be as happy as they can be. Okay, so that's the standard model. It works great. But what happens when our preferences are a little more extreme? Let's take a look at a situation where a consumer sees two goods as perfectly interchangeable. In economics, we call these perfect substitutes. Perfect substitutes are just what they sound like. For you, they're the same thing. Think two different brands of seltzer water that taste identical to you. You're always willing to trade one for the other at some constant rate. Because of this, your indifference curves aren't even curves anymore. They're just straight lines. When you're choosing between substitutes, the decision becomes incredibly simple. It's all about the deal. You compare the market price to your own personal preference. If one brand is even a tiny bit cheaper than the other, why would you ever buy the more expensive one? You wouldn't. You'd go all in on the bargain. This all-or-nothing approach leads to what we call a corner solution. You're not looking for a nice, balanced mix. No way. You find which good gives you more bang for your buck, and you spend all of your money there. On the graph, you literally go to one corner of your budget, buying only one good and zero of the other. So that's substitutes. But what about the complete opposite? What happens when you have two goods that you have to consume together, like a perfect pair? Right, we're talking about perfect complements. The The classic example that everybody uses is left shoes and right shoes. You always want them in a 1-to-1 ratio. Having 5 left shoes and only 1 right shoe doesn't make you any happier than just having one of each. It's the pair that matters. This kind of fixed ratio preference creates these really distinct L-shaped indifference curves. You only gain more happiness if you can move to a bigger L. That is, if you get more of the pair together. So your best choice is always going to be right there at the vertex, the corner of the L, where you have the exact ratio you want. So can we derive a demand curve from these rigid L-shaped preferences? You bet! And the logic holds up perfectly. If the price of, say, left shoes goes down, your budget now allows you to buy more pairs of shoes. You can reach a higher, better L curve. And when you plot these new choices, what do you get? The exact same result, a classic downward sloping demand curve. Okay, let's pause for a second. We've just built the demand curve from 3 totally different types of preferences: standard, substitutes, and complements. And every single time we got the same result. So what? Why does any of this actually matter? Here's the bottom line, and it's a big one. That downward sloping line you see in every single economics class is not just a convenient assumption. It's a map. It's a map of countless rational, happiness-maximizing decisions. Every single point on that curve is the solution to a consumer's optimization problem. The shape of the curve is a direct picture of their preferences, given their budget. But of course, this entire story has been about just one person, a single consumer. The real world, though, has millions, even billions of consumers making these choices every day. So the next big question is, how do we get from this one individual demand curve to the massive market demand that drives whole economies? Well, that's the next step on this journey. Thanks for digging into the details with me on this explainer. I'll catch you on the next one.